Hey everyone, this is Derek, and in this video we're going to look at solving differential equations, and this will be the first of two videos. This will be general solutions, and then the next one we'll do problems where we're given an initial value, and then we'll find the constant, sort of like the same we did with integration. So first, what's a differential equation? So a differential equation is an equation involving a derivative of a function. And so I'll show you this first one that's coming up. And so this is a pretty simple looking little equation, but it just says the derivative of y equals 3x to the 7th. And so with that, we're going to end up trying to solve for y and figure out what the function is. So basically, this is just finding the antiderivative in this case, like we did when we started doing integration a few weeks ago. Let me finish kind of going through these and I'll come back to that. So separable differential equation, this is when we're going to end up with these dy dx's. That's going to be our y prime is dy dx. So we're going to need to get our dy's and our y's on one side and our x's and our dx's on the other side. And if it's an equation where we're able to do that, then that's called a separable differential equation. And that's the only kind that we're going to look at in this class. And then initial value problems. So the same as when we did integration, where we would find a general with that solution with the constant c. Same thing here, and then we can be given an initial condition, and then that's going to let us find that constant, and that'll be the second video. So let me do a couple of examples. So for this first one, we have y prime equals 3x to the 7th. So I'm going to rewrite that as dy dx equals 3x to the 7th. And so remember, y prime dy dx, these are representing the same thing. They're the derivative of y with respect to x, and it's saying that that is the derivative of y with respect to x. Something I can do with this is I can multiply both sides by a dx. These little differentials, you can separate them, and that was at separable differential equations back here. And so what we're trying to do is we're trying to get our x's combined on one side, and that's going to let us do our integrations, because we're going to be taking the integral of this function with respect to dx. And then over here we'll have dy by itself, which is just like a constant 1. And then when I integrate, remember, if this had been like a 7, I would get a 7y over there. So this is a 1. So when we're integrating just like a plain dy like that, what we're getting is y equals. So that's how we're getting back from the prime to our original function. And then here we're just doing our regular old integration that we do. So we'd be adding 8, or adding 1 onto 7 to get 8, and then dividing by 8. And now this is a general solution, so it's going to have some constant c, because remember we took the derivative of this constant, it would have dropped off, so we don't know what that might have been. So that's it, that's our general solution. Okay, one more of that form. So here we have what we want to get. We basically want to get the y by itself, the dy by itself, so that when we integrate, just like on the last one, we do the integral of dy, and that gets us to y. So that kind of makes me want to get everything I can away from here. So I'm going to multiply both sides by dx. So that would put me at 4 plus x squared dy equals x dx. And now I can divide over the 4 plus x squared. So that will leave me dy equals x over 4 plus x squared dx. And so now in that spot, now I have dy by itself, or dy in any terms involving a y. And then the x is over on this side. Now I can do my integration. So do our integral. So integral dy gives us y. And then here, that is going to be a u substitution. So the denominator is a bit more complicated, so I will use that as my u. And then that's going to make du equal 2x dx, which is close. I just need to get rid of that 2, so I'll divide both sides by 2 or multiply by a half, either way you want to think of it. So 1/2 du would equal x dx, and that's what I need that to be. There's our x dx, so that's going to drop in. So this will be 1/2, And then x dx, that's going to be our du. And then this is 1 over that chunk is u. And then du. And then remember, this is going to be, when we integrate 1 over u, that's our natural log. So antiderivative on that, so that would be y equals 1/2 natural log, and then it's absolute value of u, but in this case, this is always positive, so it shouldn't matter. So 4 plus x squared, and then plus c, because that's that constant that we don't know.